Okay, so in the first steps, we find alpha. Okay, and now we need to apply the two first equations for the forces. Let me just change one thing. Let's not use OX and OY because we don't know the angles. It will be a little bit easier. So let's use ON and OT. Okay, and forget about those axes, X and Y. So we will use the same axis, so that the axis T and that the axis N, same than T and N for the acceleration. Okay, so which one first? Some of the forces on N, so I will use the space there. Let me move this. We need the free body diagrams and the kinetic diagram. Okay, so sum of the forces on N equal M A G N. So what do we have on N? We have ON. And for W, okay, so that's my axis T. And that's my axis N. Here we go. We have the angle theta. So here it's 90 minus theta. So it's theta there. So it's, oops, sorry, let me move this back. Increase a little bit, move it there. Okay, so this angle theta is there. I cannot write on top of that again. So it's plus, oh, I know, I found it. ON plus, because W in the same direction, not plus, minus. And so we say that this angle there is theta. So it's sine minus W sine theta. So that's for the two forces on N. It's equal to MAGN, and AGN, it's omega square times R. Okay, and we replace that. So ON, it's equal to mg sine theta plus m omega square, and R is L divided by 2. Okay. So that's basically what we have, and it depends of theta and W, and we do not have W. Okay, so we will see how to find W after. Let's see with the force on T. So let's square this one. We will need it later. Okay. Sum of the forces on T, it's equal to M AG T, the acceleration of T, so this one. So on T, we have OT, and we have plus, what do I click on that, plus W, and it's adjacent with the angle cosine theta. Well, M AG is equal to alpha R, what we call R in our equation, but let's replace after that. So OT equal minus mg cosine theta, the W, plus m alpha L divided by 2. And here we have everything because we have alpha. So let's replace alpha. So OT is equal to minus mg cosine theta plus m L divided by 2, and alpha is 3 divided by 2 g cosine theta divided by L. I know it's a lot, but we will simplify. OT equal minus mg cosine theta plus mg cosine theta, L divided by L, and times 3 divided by 4. So we have minus 1 plus 3/4. So OT is equal to minus 1 divided by 4 mg cosine theta. Okay, the minus is just to say that is in the opposite direction. So OT is supposed to be 1/4 mg cosine theta going up and right. Okay, so that's for the OT. And everything is given. So let's come back on the ON. We need to find omega. We have used all our equation, right? We use the moment. Let me fit everything in there. We use the force on N, the force on T, and the moment to find alpha. We have an equation, alpha of theta is equal to 3 alpha of g divided by L cosine theta. Let's rewrite this one. That's this one that we found. When we have alpha of theta, how can we find W? So if you look on your formula sheet, with the rigid body motion about a fixed axis, we have alpha equal dW divided by dt, not helpful. Theta, W equal d theta divided by dt, not helpful. And the last one, omega d omega, it's equal to alpha d theta. Oh, here we have the function alpha of theta. So we can write that omega d omega, it's equal to alpha 3 half g divided by L cosine theta d theta. And we can take the integral on both sides, right? So between omega it's equal to 0 because it's released, if it's released from rest, to, and if you want we can use a omega 0, but let's say it's released from rest to omega because we want to find omega for any distance from 0 to theta. So we have omega square divided by 2 on the left, and it's equal to, so 3 half g divided by L, the integral of cosine theta d theta. So omega square, so we can remove the 2 on both sides. So omega square is equal to 3g divided by L, and the integral of cosine theta, it's sine theta. Yes. So sine theta minus sine 0. Oops. And sine 0 is 1, so omega square, is it 0? Yes, from 0. If we consider that the angle theta is there. So we can consider 3g divided by L sine theta. Oh, sine 0 equals 0. We're thinking sine 0. So that the function omega of theta is the square root of 3g divided by L sine theta. So we are able to find omega for any angle theta. So for example, if theta is equal to 90 degrees, it means sine theta is equal to 1. So omega will be equal to the square root of 3g divided by L. So depending of your L. And with this omega, we can find ON. So let's use these equations and these equations. So ON is equal to the mg sine theta plus, let's write ml divided by 2, omega square. And you see, it's omega square. So let's use right away 3g divided by L sine theta. So ON is equal to mg sine theta plus LL, so 3 half mg, yes, mg sine theta. So ON it's equal to, I just check I didn't forget any sign. No, I think I'm fine. So 3 half plus 2 half, 5 half of mg sine theta. So we are able to find the ON for any angle. So you can check for some specific angles to see if it's correct. So yeah, redo this Slender road and use, for example, I try to have everything on the final video, so you have everything. So I will recommend try, for example, and you see the mass. Oh yes, the mass is important for ON and OT, but not for alpha and not for omega. Okay, so let's, for example, try all those formula using a mass of, I don't know, 5 kilograms and a length of 1 meter. And what else? and an angle theta, for example, at, so 0, remember the 0 is this, that's theta equals 0. This one is theta equal 90 degrees. You can use theta equal, I don't know, 45 degrees, theta equal 90 degrees, and see if everything makes sense. For 90 degrees, for example, what makes sense is that, so for 90 degrees, your cosine is 0, so OT will be 0. That the horizontal, it will be horizontal, that makes sense, and this one will be maximum. Yeah, those formula make sense. So that's it for the demonstration for the slender road. That was fun, right? Oops. Oops. And oh, I cannot put it back. Sorry. Remember? G sine theta. Let's keep it this, and let's clean that. Here we go. I hope you enjoy. Bye bye.